In this reaction, we have an electrolytic cell and we have an aqueous salt. So it's dissolved in water, and we're asked for the reaction at the anode. Now, because water is involved, we have to take that into account. One of the things I get in the habit of doing is listing all the possible reactions that we could be working with. So one of them is the 1/2 O2 plus 2H plus 2 electrons, and that's a H2O. That's plus 0.82 volts on the redox table. Then we have I2 plus 2 electrons, giving us 2 iodide ions, and that's at plus 0.54 volts on the redox table. Then we have 2 water at minus 0.41 volts, and we have sodium. Now with electrolysis, we want an oxidation on top, a reduction on bottom, and we want the pair that's closest together. So let's look at what we actually have in this situation. We are starting off with water, with iodide ions, with water, and with sodium ions. So you can see that the most likely combination that we are working with here is this pair where the oxidation's on top, the reduction's on the bottom. We're not going to be wanting the outer extremes because electrolysis involves working with the closest pair. We want to spend the least amount of electricity for this to work. Therefore, on the top here, this is our oxidation reaction, this is our reduction reaction, and since we want the anode, we're looking at the oxidation reaction, and the reaction we'd be looking at is 2I minus, going to form I2 plus 2 electrons. The substance formed at the anode will be iodine.